Hello, today we're going to continue talking about dilation and the similarity that can be seen from dilations. But first I thought I would talk about some review topics for you guys. So our objective is ultimately we can define and utilize the triangle side splitter theorem. And some of the vocabulary we're going to use are ratio, proportion, side splitter theorem, similar, dilation, and parallel. But before we really begin that topic, I just wanted to review a little bit of some old information with you in sort of a new way. And so if we look at this diagram, what it says is suppose two triangles ABC and ABCD share the same base AB such that the points C and D lie on a parallel line to AB. And so as you're looking at this, you've got C and D, they're on a parallel line. Okay, and from there you can see the triangles. And so we've got this green triangle paired up with this blue triangle. And there's something else that's really important. That they share the same base, and so I'm just going to mark that with X. So they share the same base, AB. Okay, and they want to know which area. So if I were to find my find, there it is. Find. All right. Show that their areas are equal, or which area would be greater if we thought they were greater. And basically, what we have to understand about this is that the area of a triangle is 1/2 base times height, where height is the altitude from vertex to base. And the base can be extended. Okay, and so if I'm looking at that, this is the height of my triangle ABC, and this is what I mean by extended base. Notice this doesn't actually hit the green or blue, so they extend it along that line, and so this is the height. And what we have to understand is that the heights are equal because lines are parallel. For this particular problem, so let's go with height ABC, so height of C, and ABD, so let's go height of D. For this particular problem, the height of C is equal to the height of D because lines are parallel. So what does this mean? It means for triangle ABC would equal 1/2 base times height of C, and area of triangle ABD would equal 1/2 base times height of D. But I know I can replace the height of D with the height of C, which means the area of triangle ABC is equal to the triangle area of ABD. Okay, so it's just refamiliarize yourself with the formula, just in case you had forgotten. It's good to remember these things. So area of a triangle, and then just thinking through a type of problem like that and knowing that you can have an altitude that ends up being the same implies that the areas will also be the same. And so an extension of that is as we look at ratios, and we've seen a lot of ratios in the last few videos. So suppose two triangles have different length bases. So ultimately what I'm comparing is AB with AB prime. And they both have the same vertex C. So you do have to read these questions to make sure you completely understand. And so if I'm comparing the areas of the triangles, I'm really looking at the pink area versus the green area. Okay? Show that the value of the ratio of their areas is equal to the ratio of the lengths of their bases. And so we can do this mathematically. If we use what they gave us already, we know that the area 1/2 base and the base for AB, so let's just call that base B times the height. Since it's the same point, this is really easy to see how the heights are the same. Divided by 1/2 base, and that's B prime's base, so AB times the height. But since we have the same number in both the numerator and denominator, that makes a 1. We have the same height, that makes a 1. And so what I'm left with is the base of triangle ABC over the base of triangle AB prime C. But we know the base of ABC is really just AB, the length of it. Oh, and the base of triangle AB prime C is just AB. And so we've essentially established the exact thing they're having there, as long as we understand the relationship of the formula and the bases. And so what it's saying is, because of the consistency of the height, we're able to kind of make an extension. So just warming you guys up with some background information, and now we'll get on to the important stuff.